Hey YouTube, so I'm back again because surprise surprise for me, I just got another one of my orders come in, and these are BPW34 PIN photodiodes. Uh, Now these are quite interesting because their spectral response reaches into the infrared range, which is what I was primarily interested in, but also in that they are uh, pretty cool little solar cells in and of themselves. So these weren't terribly expensive. I think I paid about $4 for the five of them. And they can be used for all kinds of little self-powered board energy harvesting projects. So what I plan on doing here is we're going to analyze these. We're going to see, and we're going to characterize their outputs under these variable lighting conditions of direct sunlight and indoor light exposure. So without further ado, we'll flip this camera around, and Ginny, I'm going to ask you not to play with your Play-Doh right now, okay?
Okay, I'm just smelling them.
I know, but I'm going to ask you not to play with it right now because it's going to shake the table, okay?
Okay.
All right. Now, so first off, we're going to need to use our handy dandy little meter, and we're going to see which side outputs positive, which side outputs negative. Take the five of them out, and we will get most of them arranged on the breadboard first. And we'll just take the one. Ooh, these are small pieces. So on the one side, you may or may not be able to see it, but there's a little tab here, and that denotes your positive and your negative. So I'm just going to go ahead and I'm going to get it laid out in my breadboard. I'll get the four of them laid out, and then once they're safely lodged inside of my breadboard, we'll take the fifth one and we'll start characterizing it. So there's two, there's number three coming in here, and number four. Now what we have to remember is that there is limitations for what we can expect to get out of this, because under the best conditions, solar light only provides a maximum of 1,000 watts for every square meter of surface area that you are receiving. And then you also have to remember that solar panels are only so efficient. So there are going to be limits as to what is achievable with this surface area on these little diodes. So let's get our meter turned on, and let's see what kind of voltage we're going to get off of a single one of these little diodes. So right out of the gate, we're going to find out which side is the positive. And actually, you know what? It may even be easier to do this while it is on the breadboard itself. We'll just look at one of them. So we'll stick that in here, and I will use one test lead and another test lead over here. So we have 334 millivolts here in the shade. I'll prop this up.
Dad, look at the tall tower we made.
Yeah, that's pretty nice, Junie. Remember I was asking you not to play with your Play-Doh at the table right now?
I know.
While you're playing with it. Anyways, so we have 334 millivolts. We'll double check that.
1, 2, 3.
So 350, 354. Now, if I put this in the sunlight, I'm getting half of a volt. And if I tilt it, I'm getting all the way up to 525 millivolts.
1, 2, 3, 4.
That's good counting, Junie. But do you think you can do that somewhere else or do it a little bit later after I'm done the video?
Okay.
Okay.
I'll do it later after the video.
Yeah. Now, let's see how much amperage this makes. And you know what? I'm going to switch strategies a bit. I have these little things that I can use so I can plug directly into my voltmeter. It might even be the way I should have done it from the start. So now we'll take this, put it in here, and this one, put it in here. So the side with the tab on it happens to be the negative, and the side without the tab happens to be the positive. Here I'm getting 361 millivolts, and now we'll see. Well, how many microamps are we getting? Are we even getting a microamp? That is that is a question in and of itself. So, wow, right out of the gate in the shade over here, we're getting 16 with it pointed directly straight up. We're getting 24 microamps. If I point it sideways, we're getting 11, 12 microamps. And if I stick it in the sun, wow, it's like 750 microamps. For such a small cell, that's amazing. And if I get it angled correctly, we're getting over a milliamp from this tiny little cell. Isn't that amazing? Over a milliamp at half a volt. So that's awesome. And of course we have this hooked up in series. So if we follow the series line down, I know they have lots of reflections. So again, here in the shade, we're getting this 20, 21, 22 microamps. And if we stick it back out in the sun, takes a little bit of time to respond, and of course we have the bit of variances between, but I'm getting almost a milliamp. And if we grab this little piece over here, stick it back into the voltage side, and we get our voltage reading, here in the shade we're getting a total of 1.8 volts, and out here in the sun, up to 2.61 volts. Now isn't that something? So these little BPW34 solar cells, they really are quite the impressive little solar cells. Obviously they're very efficient per unit area, and I'm excited to see, you know, what ideas can I come up with going forward to make use of these little cells for the purposes of energy harvesting. They are, in my opinion, they're quite amazing. Anyway, we'll see you, YouTube.